All right, 7.3 complex numbers. So we're going to look at a brand new number system here. It's going to be an extension of the real number system. It's going to allow us to do some things that we can't do in the real number system. And so we have those. And there are plenty of different number systems based on our needs. Everything was created based on the need of the math, okay? Going from originally just having counting numbers to then adding a zero to then adding negatives, and decimals and fractions, and that's what's created the real number system. But over time, we've needed to create what's called a complex number system as well, okay? And so we're going to look at that here today. All right, so let's define those things. So the first thing that we need to define is the number I. Okay, so the number I is defined such that I equals the square root of -1 and I squared equals -1. Now we're defining that. That's what we're saying it is. So by law, we can't change that, okay, for those pieces. So we're not manipulating stuff, any of those things. We are simply saying that's what's happening for those, okay? So now what that does allow us to do is to start talking about negatives inside of radicals and changing those things over. You're going to see some of that later on, how we're going to work with that, okay? All right, the second definition here is the actual complex numbers. This is a number in the form A plus BI, A plus BI, where A and B, I'm gonna rewrite that. Sorry, didn't like the way I did that. So where A and B are elements of the real number system. Okay. The number A is said to be the real part. And the number B is said to be the imaginary part. So another term for this I, because it's I, we call it the imaginary number with those, okay? And we've made that part of the terminology there. So we talk about imaginary numbers, we're talking about I and square root of -1, those types of things, okay? So if you ever hear us speak that verbiage for those. But when we break this down, we have a real part, because if this is 0, it's just a real number. And then over here, we have an imaginary part for those, okay? And so anything in that form is considered to be a complex number. And then our last definition is complex conjugates. Now we've used that term conjugate before, and so it's the same thing, it's just dealing with complex numbers. So a complex conjugate is if we have A plus BI and A minus BI for those things. So again, just the sign change in the middle, nothing different about those pieces. And so we just continue with that same process, okay? All right, examples. Simplify. Now we have different ways of simplifying based on what they give us. We're going to have some adding, subtracting, multiplication, but we also have another way of looking at these numbers, okay? And so here, let's do I to the 11th power. I want to know what that is. Okay, can I break this down into something simpler? Okay, now there are a few different ways to look at these when we talk about powers, but we're going to kind of break this one down And then I'm going to talk about some other ways as well, okay? All right, now, I to the 11th, we don't really know much about that, but we can break it apart and look at some other pieces of it, okay? Now, since this is an odd here, it's 11, I want to talk about evens because we know this square is -1. So that lets me do some reducing later on if I have some evens. So I need to turn this into an even, so out of the 10th times out of the 1. Okay, I'm going to put a 1 there. You don't have to do that. I'm just doing it for emphasis on this problem. But 10 plus 1 is 11. Okay, that's where it's coming from. All right, now, why did I do that? Now we have an even. We have I to the 10th. That's even. So I can actually break that down into I squared to a power by dividing. Well, that means it's I squared to the 5th power, and then we still have this I on the outside over here, okay? Now again, let's look at that math. 2 times 5 is 10, plus 1 is still I to the 11th. So our math is still there. We're just separating pieces out so we can do things with it, okay? All right, well, I squared, we already know I squared. I squared is -1. Okay, by definition, I squared is -1. So now I've got rid of that part of the I, and I can start doing some math work with that. Okay, well, -1 to the 5th power, that's -1 times I. -1 times I is just -I. So what I was able to do there is take this big ugly power and turn it into an I without a power. That's a -I, and that's okay. But we can do that, all right? And so we want to be able to break those pieces down and work from those. Now, what you're going to see is that over time, we have I is going to give me I. All right? I squared is -1. We do that math. I to the 3rd is going to give me -I. And then I to the 4th is going to give me 1. All right. Now, I to the 5th is actually going to go back up here and give me I. Okay. For those. And then this one's going to give me I to the 6th, I to the 7th, I to the 8th. So everything can be related down to those 4. This one's going to give me out of the 9th, out of the 10th, out to the 11th, out of the 12th. Notice there that out to the 11th is -I, which we got just a moment ago. Okay, and we could do that. So technically, you could list them all out just like I've done over there, but you're going to have problems where we're going to look at out to the 70th, right? We don't want to have to list that many. And so that's where this process makes it a lot shorter than trying to write them all out. Okay, and so we want to do that. So let's look at a couple more of those examples and see how we can work through that and reduce those. And so as I'm writing that, getting my paper and writing that down, your goal here is to not have powers on I is why we're doing this. So I to the 64th power. I to the 64th power. All right, well, that one's already even, okay? Since it's even, we don't need to break it apart into another I. We just need to deal with that power because we've already got it I squared to something. So I can turn this into I squared. Well, 64 divided by 2 is 32. Okay, so if it's even, you can go ahead and separate the I squared off. If it's odd, I've got to take one off and then separate it. Okay. Well, I squared is -1. -1 to the 32nd power. That's going to make that a +1 with us. Okay. 3. -I to the 71st. Okay. -I to the 71st. All right, now even though it's a negative I, we're still going to do the same thing. Okay, we're going to separate. We see it's an odd power, so we're going to separate this negative I to the 70th. We're subtracting 1 times negative I. Okay, taking that, what's inside the parentheses out. What are those? All right, well, negative I to the 70th, we can rewrite that as negative I squared to the 35th. Now notice I've got a double parentheses there with that because this is already in parentheses. I've got to keep it in parentheses even when I move that square on it. Well, let's do that real math. What does a square do to a negative? It makes it positive. Okay, so that I does become positive there. All right, then finally here, the I squared is a negative 1 to the 35th times negative I. And then 35, that's an odd power. It doesn't change that, so it stays negative 1 times negative I. Negative times negative makes a positive I for those. Okay, so we still end up at the same place on those. We can still get those powers off. We just have to break things down and take a little bit of time with it. Right. Now, I will admit that's probably the harder concept of today with those. So let's look at maybe some easier concepts and deal with those pieces. Okay. All right, square root of negative 25. Square root of negative 25. Okay. All right, now before, when it had a negative, we couldn't do that. But because we're in the complex number system, we can now. And so we're actually going to separate this out. I'm going to look at this as the square root of negative 1 times the square root of 25. Okay? Because we know those things, right? We've just learned today that the square root of negative 1 is I times the square root of 25, which is 5. Now, we don't write it this way. We like to think of that as a kind of like a variable. So we don't put x5, we put 5x. Same thing with the I, we put 5i on those. Okay. All right. How about the square root of negative 24? This one, isn't it? We've got to simplify the whole thing. All right, now we do want to break it apart. We want to think about our pieces. Now, you don't have to do this step right here. Okay, this negative coming out is going to be I every time. So I need to take that negative out. So I can just go ahead and rewrite this as I square root of 24. Okay, so I'm going to do that every time with those. Now we need to simplify that 24. Well, we know that that is 4 times 6, and so we're going to get square root of 4 is 2, I square root of 6. Write that 2 a little bit better. Okay, and that's going to be our simplified version. Now, be careful with those. You'll see that if you work this in Pearson, if you do the help me solve this, this is the same as 2 square root of 6 with the I afterwards. I don't like to write it that way because then it may look like the I is underneath the radical. We want to make sure that does not happen. So that's why I put it in front with the 2 so that it doesn't end up underneath the radical. Either one of those are correct as long as you write it. You stop your radical before the I, they are both correct. But I would get in the habit of writing it this way. You'll see most mathematicians do that. Okay. All right, number 6, 12 plus 3i plus negative 8 plus 5i. Well, the good thing here about adding and subtracting is I can be considered just like any other variable. So we are combining like terms. There's nothing magical about those. So we just do what we've always done. So 12 plus negative 8 is 4. 3 plus 5 is 8i. Okay. So nothing super crazy about those things. Okay. 6 minus 4i minus -5 plus I. Now, I would recommend, as always, that you go ahead and distribute this negative first here. So 6 minus 4i is going to be plus 5 minus I. And so 6 plus 5 is 11. -4 minus 1 is a -5i. Now, you do need to put in that order where the I piece comes second. Your instructions in your homework are going to say put it in A plus BI form, which means the number without the I first, the number with the I second. So do get in the habit of doing that. All right, so adding and subtracting, real straightforward there. So let's move on to multiplication. So 7i times 2 minus 5i. Well, starting off, everything is exactly the same. We distribute and then combining like terms. So here we're going to distribute. We're going to get 14i minus 35i squared. We do have to remember something here, okay? I squared, that's -1. So we need to get rid of that. Anytime that we can convert those powers down, so we should never have I with the power on it. We should always convert it over for those. So really what we have here is 14i, -1 times -35 is a positive 35. And then we have to write it in the correct order of 35 plus 14i. Okay, so we need to change that every single time. Okay, so I'm looking for that, and the computer will be as well. All right, well, if we can do monomials, we can do binomials. So again, we just FOIL that out for those pieces. And so 1 times 1 is going to be 1. I'll mark her out here. So we've done that one. We're going to get -4i plus 3i minus 12i squared. But again, that's going to be -1. So I'm going to rewrite this 1 minus 4i plus 3i plus 12 because the double negative. And then combine by like terms. 1 plus 12 is 13. -4 plus 3 is -1i, or -i. Okay. So let's do another couple of those. All right, so again, just simply FOILing that out. So we're going to get -12 plus 8i plus 3i minus 2i squared. That's going to give you that -1 there. So let me rewrite that problem. And so combine our like terms, we're going to get -10 plus 11i. So once we identify those powers, it's really the only difference that we have on those pieces, okay? So let's do one more as I want to see something special here on this one, what's going to happen here for these. Now, when we look closely, this is conjugates, right? We have just a different sign in the middle of those. Everything else is the same. So we're expecting something special to happen here. Let's work it out and see what does happen for these, okay? All right, so we get our 25 here, plus 20i, minus 20i, minus 16I squared. Well, here, those are going to cancel out, and conjugates are always going to do that. Just like we talked about previously on some multiplication pieces, that's going to always happen. And that's going to be -1. So we actually got 25 plus 16. So 25 plus 16 should be 41. Now, with these, that's going to happen every time. The middle ones are going to go away. So what you can do is square the first, square the second, and put a plus in the middle for these, because the I is going to make a plus. The I squared is going to make a plus every time. And then add it. So you can skip this step here and jump straight from here to here moving forward. We're going to do that in the next problems. Okay. Right. Number 12. So 3 over 5 minus 11I. Well, an I is a square root. And just like we talked about in chapter 6, we do not like radicals on the bottom. So we don't like i's on the bottom of our fractions. So we want to get that off. Okay. And so that's what we're going to start with here on these. Now, to get that off, just like we did with the radicals, without adding and subtracting, we're going to use the conjugate. So let's do that. So the conjugate here is going to be 5 plus 11I. Right? Now on top, when we multiply there, we're going to get 3 times 5 is 15. 3 times 11 is 33I. Now on the bottom, we're going to use that trick. Okay, so 5 squared, that's 25. We're going to put a plus. 11 squared is 121. So now we can put those together. We get 15 plus 33I over 146. Now we do have to still write it in that A plus BI form and see if we can reduce. So we're going to get 15 over 146 plus 33 over 146I. Now the 15 and 146 do not reduce, neither does the 33 and the 146. But if you can reduce those fractions, you need to do so. And so this is our final answer. Right, 4 plus I over -3 minus 2I. Now it doesn't matter what's on top, we still want to do the conjugates here and break this down. So we're going to multiply. We also don't care that that first one's negative, it stays negative. So -3 plus 2I. Okay, so we got to be careful with that when we are multiplying those out. We only change the sign in the middle. All right, so up here we need to FOIL all that out. So 4 times -3 is -12. We're going to get 8I minus 3I plus 2I squared. And then on the bottom here, we're going to get 9 plus 4. Okay, I squared the 3 to get 9, squared the 2 to get 4, and then the negative, that becomes plus down here always. All right, so that's a -1 for those. Okay, I'm going to go ahead and do some combining here. We're smart enough to be able to do that. So this is really -2 and -12, which is -14. 8 minus 3 is 5. And then 9 plus 4 is 13. Okay? So we do need to separate that. So -14 over 13 plus 5 over 13I for our final answer. Okay? So you're allowed to do that shortcut up there as well. So if you put that -1, you realize that changes the sign. You can go ahead and combine those just like we've done before. Okay. All right, let's do one more, and that'll wrap us up here for this section. 2 plus square root of 3 I. So they're going to have it written this way, so I'm going to write it down that way, but I'm not going to leave it that way after this. And then 5 minus 4i. Okay. All right, so we still do our conjugate here. So times 5 plus 4i, 5 plus 4i. And so on top, let's go ahead and multiply that out. We're going to get 10 plus 8i. Here, that's going to give me plus 5i square root of 3. So I'm putting the 5 in front. I'm moving the I in front as well, because I just don't like that in front or after the problem there. And then for our last one, we're going to get plus 4i squared square root of 3. Okay, so when we multiply here, we still get the I squared. And that I squared is going to be a -1. I still need to do the bottom, right? 5 squared is 25, 4 squared is 16. Now on top, even though I'm changing that, nothing's going to go together. So we are going to write it though. We're going to put i's next to each other and numbers without i's. So we have our 10. This is no longer going to be an I. I'm going to write that as -4 square root of 3. And then over here, we're going to have plus 8i plus 5i square root of 3. And then on the bottom, we're going to get 41. So now we're just really trying to get it in the right order. We're trying to make it look the way the computer wants it and how it should be written. Okay. So we still have to break it apart into the a plus bi. All right. Now the stuff without an I, we put on the first fraction. So 10 minus 4 square root of 3 over 41. Plus. Now over here, we are going to write this other stuff, but remember, we like to put that I afterwards. So we're going to take the i's off and we're going to put 8 plus 5 square root of 3 over 41, and then the I afterwards. And all of that ugliness is your answer for that one. But we did get it in the right form. We got the I off the bottom of the fraction for those pieces. Okay. So that's probably the ugliest one of those. These others aren't as bad when we're looking at those pieces. Okay. But you got to pay attention to those powers on those I's so that you do things correctly and put together the right pieces.